In section 9.3, we're going to look at a small subset of this material. In particular, we want to discuss the concept of explained versus unexplained variation in our linear regressions. The first thing we're going to discuss is what's called the coefficient of determination. We already know how to calculate the correlation coefficient, which is sometimes called the Pearson R coefficient, by using our linear regression technique in our calculator. So as a review, one of the things you should have already done in our calculator is to have turned the diagnostic tool on. So for those of you using the TI-83 or the TI-84, the way we did this is we went under the catalog. So we went second, catalog. You would scroll down until you would find diagnostic on. We would hit enter to put it onto the home screen, and then hit enter again to activate it. And now every time we do a linear regression, for example, let's suppose I enter some data. If I had a bunch of X and Y values, I'd put them in my stats menu. I would go to edit. I have a data set in right now with a bunch of paired data. My X values go in L1. The corresponding Y values go in L2. And then we would go to stat. To conduct a linear regression, I would simply go over to calculate, and for us it's always option 4, which is linear regression. Make sure that your list L1 should be under the X list, the L2 list should be under the Y list. We're going to go ahead and hit calculate, and with that diagnostic tool on, this will not only calculate the correlation coefficient for us, which is R, but it also gives us the coefficient of determination, which is R squared. Okay. Notice that if we had just been given the value of R, so let's suppose that somebody tells us the value for R, for instance, is like 0.535. So I'm just going to round it a little bit. So 0.535. If this is the correlation coefficient, which is R, then to find R squared, you literally just take this value to the second power, hit enter, and that's how you would calculate the coefficient of determination. Okay. What is the coefficient of determination? So remember, the thing that R gave us, so the value R, which is the correlation of coefficient, that was a measure of the strength of the linear correlation between the X and the Y variables. The closer it is in absolute value to 1, the stronger the relationship we have. With a extreme of -1, which would correspond to a perfect negative linear correlation, and a positive one, which would correspond to a perfect positive linear correlation. What R squared tells us, R squared is the ratio of the explained variation to the total variation. So at its heart, what R squared is, it's the ratio of your explained variation to the total variation. For example, if we wanted to calculate R, let's suppose that somebody told us that the correlation coefficient R was about 0.900, then to calculate the coefficient of determination, we would just do 0.900 square, and that would give us 0.81, which would be the coefficient of determination. Again, at the end of the day, we always want to ask the question, what does this mean? Well, the summary of this would be we would change this decimal to a percent, and we would claim that 81% of the variation in Y can be explained by the relationship between X and Y. So 80% in the variation of the Y variable is explained between its relation with the X variable. What would be left over, which would be 1 minus R squared, which would be 19%, you can just simply subtract it from 100, 100% minus 81%, leaves us 19% that's not accounted for. That means that the remaining 19% of the variation is unexplained and would be due to other factors, things like sampling error, coincidence, or lurking variables. In the perfect positive and perfect negative case, notice that 100% of the relationship would be explained by the factors between X and Y, and there would be 0% would be unexplained. Let's take a look at example 1. They give us the correlation coefficient R, which is 0.874, and they ask us to calculate the coefficient of determination, which is R squared. We would simply take 8.74, square it, and rounding it to 3 places, we would get a coefficient of determination R squared would be equal to 0.764. So 0.764. To summarize our conclusion, the interpretation would be that 76.4% of the variation between the variables, which is carbon dioxide and gross domestic products, would be explained by the variation between those two variables, and then about 23.6% of the variation would be unexplained due to other factors. And typically those other factors include things such as sampling errors, coincidence, or perhaps even things called lurking variables.